Okay, this is the video on completing the square. So hopefully you finish this investigation up to the notes part. Completing the square is all about factoring things that are difficult to factor by making them into something easier to factor. So if you look at x squared plus 6x plus 8, that's a little bit difficult to factor. Same thing with p squared minus 5p plus 4. And it doesn't always turn out super easy. So what we want to do is we want to force it into something that is easy to factor. So if you look at this one, this is a perfect square trinomial. It's easy to factor because it's x plus 4 plus x plus 4 equals 0. Or you can rewrite that as x plus 4 squared equals 0. Then take the square root of both sides and get x plus 4 equals square root of 0 is still 0. And then subtract 4 from both sides and find that x equals negative 4. Okay? A lot easier than having to do your box method, right? And finding sort of how it goes, and sometimes it doesn't go unevenly. Okay, so we're really forcing something easy to become one of these. So, for example, I'm actually going to do this one first. So, for example, I have x squared minus 14x plus 16. Let's talk about why this is difficult to factor. The factors of 16 are 1 and 16, add or subtract, doesn't add up to 14. 2 and 8, add or subtract, still doesn't add up to 14. 4 and 4, no matter what you do with those, still doesn't add up to 16. So this is a difficult one to factor because it's not immediately obvious, right? So let's take a look at this x squared minus 14x plus 16. You know what would be really cool? I feel like if this was x squared plus 14x, x squared minus 14x plus 49, it would be really easy to factor because it would be x minus 7 and x minus 7. This is a perfect square trinomial, which would be the perfect square trinomial for this. So, I have an idea. What if I took this and I turned it into that? I have to do this all using legal moves, right? But I think I can do it. So the first thing I want to do is, I don't like this 16. I want it to be 49. I don't like that 16, so I'm going to get rid of it. So I'm going to subtract 16 on both sides. X squared minus 14x equals negative 16. That's great. It didn't really help me factor, though, because it's not 0, right? I can't split it up and use a zero product property. But I can now force this to look like this, right? I can now use 49 instead of 16. So I want this to be x squared minus 14x plus 49, and that's only legal if I do it to this side and to this side. But it's legal if I do it to both sides, right? Remember the golden rule from Algebra 1A. So then I have x squared minus 14x plus 49 equals, and on the other side, I have 33. Now I can go ahead and factor the left side, ignoring the right side. Well, I told you before, x squared minus 14x plus 49, well, that factors into x minus 7 and x minus 7, which is x minus 7 squared. And now this turns into one of those really easy problems that I can do without having to factor, because it's already factored. And I can go ahead and take the square root of both sides, and I would get x minus 7 equals, and you might want to just plug this into a calculator, about 5.74. And x minus 7 equals negative 5.74. Remember, negative times a negative gives you a positive, positive times a positive gives you a positive. Now I can solve both sides of my equations here. And that would give me 12.74. And 1.26. So if I were to graph this, I would have two roots. One would go through 12.74-ish and 1.26. Okay? So let me kind of recap what I did there. I took something that wasn't super factorable, and I forced it into something that was. And then once I did that, I was able to take the square root of both sides and move on from there. So let's go ahead and see this with our notes here. It kind of lays out nicely the steps for us so we can kind of do it one piece at a time. So first off, divide each term so that the leading coefficient is 1. Well, the leading coefficient here, there's not one, which means it's negative 1, so we're done. We don't have to do that stuff. But then we want to force this into x squared plus 6x plus 9, because that would give us x plus 3 squared. So I have to get rid of this 8, so I'm going to subtract 8 from both sides, That would give me x squared plus 6x equals negative 8. Now, I can add 9 to both sides here so that it turns into this. You might be asking yourself, well, how do I know to add 9? Well, there's this nice little formula here, this b squared, or b over 2 squared, that gives us that last piece, okay? Remember, if we're talking about ax squared plus bx plus c, in this problem, b is 6. So b over 2 would be 6 over 2, which is 3, and 3 squared is 9. So that's how I know to add 9. So I'm going to add 9 to both sides. That gives me x squared plus 6x plus 9 equals negative 8 plus 1, or plus 9 is 1. And now I can go ahead and write my quadratic as a square. I force this into x plus 3 squared, and I know it equals 1. I can take the square root of both sides. That gives me x plus 3 equals positive 1, and x plus 3 equals negative 1, and then I can continue solving. Subtract 1 from both sides, I get x equals negative 2. Subtract 3 from both sides, I get x equals negative 4. So my two roots are negative 2 and negative 4. Okay, let's take a second and look at this one here. It's the same sort of process. Again, my leading coefficient is 1, so I don't have to worry about it. So I would subtract 4 from both sides because I want to force this into p squared minus 5p plus whatever would make it a perfect square trinomial. You know what? I don't know what this is going to be off the top of my head. So again, I'm going to use this formula. So it would be negative 5, which is my b, over 2, which is negative 2.5, and that squared, which actually ends up being 6.25. So I know I have to add 6.25 to both sides. So p squared minus 5p plus 6.25 equals, you might want to use a little calculator for this one, just to double check, 2.25. Now, I know that this is a square because I forced it into one, so it's going to be p. And then if you take in your calculator, and you don't necessarily have to do this if you already understand what it is, but if you take in your calculator square root of 6.25, you get 2.5. Oh, that's interesting. That's b divided by 2 squared equals 2.25. Now I can take the square root of both sides. That gives me p plus 2.5 equals, so square root of 2.25 turns out to be 1.5. Who knew? And I also have to have my negative 1. So p plus 2.5 gives me 1.5, and p plus 2.5 gives me negative 1.5. Now I can subtract 2.5 from both sides, which would give me negative 1, and negative 4. So again, the idea is that I'm forcing this really difficult thing to factor into something that's easier to factor by making it a perfect square. That's why it's called completing the square, right? You're not factoring it into sort of a rectangle. You're really trying to make it into a square as much as possible so that you can solve it kind of using this method that you learned last week.